Well, hello, everyone. It's so great to have you here today with us. I'm Liz Harvey Roberts. I'm the Chief Development Officer for the California chapter of the Nature Conservancy, and I am very happy to be your hostess for the future of webinars. And we have a very special guest today to talk about the future of oceans, and that's Tom Dempsey, who is our Director of the California Oceans Program for the Nature Conservancy. And before we pass it over to Tom, I just want to say I had the blessed opportunity to visit Palau in June this year and to visit with some of our Micronesia staff who live there and to learn about our fisheries program and have the chance to snorkel in a lot of beautiful spots and learn about how the island nation of Palau has really been dedicated to the preservation of land and oceans for decades. And I'm very happy to say that the Nature Conservancy was a very early organization to help them do that. So with that, I would just love to hand it over to Tom and to also let you know that we have a few questions that we will be asking to get us started after Tom's presentation. But if you're thinking of some as you're hearing Tom's remarks, please do put them in the Q&A function and hopefully we can get to them. So with that, Tom, please take it away.
Great. Thanks so much, Liz. And let me share my screen here. We can get started. Well, hello, everyone. As Liz said, my name is Tom Dempsey. I'm the director of the California Oceans Program, and I'm just thrilled that you're all able to join us today and interested in this topic. And before we step into the future of oceans, and before we talk about some of the current issues that are shaping that future, I want to just step back and get a little bit of perspective. This cloudy blue marble is our home. Astronomers estimate that there are 700 quintillion planets in the universe, but this beautiful, strange rock floating in space is unique from all other known planets for one reason: oceans. Life on Earth exists because the planet is covered with water, more than 70% of the Earth's surface today. And from the earliest human societies and onwards, people have been fascinated by the ocean, by its beauty and bounty, its power and possibility. And while cultures around the world have thought about and engaged with the ocean in radically different ways across human history, oceans matter to all of us. Without healthy oceans, life cannot survive on this planet. They are quite literally Earth's primary life support system. Altogether, oceans support more than 1 million species, many of which are still largely unknown to science. Oceans make our weather and our storms, and they're not only important to the rhythms of nature and marine life, they also provide essential benefits for people too. Oceans provide more than 3.1 billion people with sustainable protein, and that's about 4 out of every 10 humans that are on the planet today. But even more fundamentally, oceans make the very air that we breathe. The oxygen in every other breath that we take comes from photosynthesis that happens in the sea. And oceans also play a really central role in absorbing as much as half of the carbon that humans have emitted since the Industrial Revolution, storing more than 50 times what's absorbed by Earth's atmosphere. So, as I said, the future of our planet depends on the health and resilience and abundance of our oceans. But the world's oceans are in trouble. For a very long time, a lot of people just didn't believe that human actions could ever meaningfully diminish the health of our oceans or drive a marine species into extinction. But we certainly know better now. Humans have had a devastating impact on the world's oceans over centuries of overharvesting and habitat destruction and pollution. Despite all that they provide for us, humans have often treated the ocean with a fundamental lack of respect. And now a lot of these changes and forces and threats are being exacerbated by the accelerating climate crisis. Oceans are warming at an alarming rate. Over the last 30 years, we've seen a 450% increase in the rate of warming when compared to the prior 30 years. And as a result of all these changes, ocean species and ecosystems are being pushed to the brink of collapse. At the same time, global plastic pollution is accelerating and threatening marine species in a host of ways that we're only now beginning to understand. Overfishing is crippling some of the world's most important fisheries. Globally, in total, we've lost more than 1/3 of some of our most important coastal and marine habitats, from coral reefs to kelp forests, from seagrasses to mangroves. Human actions are eroding the very foundation of healthy oceans. And island ecosystems, which are global hotspots for biodiversity and deeply connected to the health of our oceans, are in steep decline all around the world. Now, I wanted to pause there. The breadth and scale of the challenges confronting ocean health today are daunting. And it's hard, at least for me, to step back and just take a clear-eyed look at all that we're dealing with now without a deep sense of sadness and even anger. As I said, the future of humanity relies on healthy oceans. And when I look at all that we have done and all that we are doing, when I look at the choices that humans have made and continue to make and all the problems we now have to solve, it can be overwhelming. But I need to remind you that just a few generations ago, our oceans were abundant and resilient. And TNC's science shows us that they can be again. To achieve a future of abundant and healthy oceans, TNC is advancing a new and bold vision of ocean recovery, one focused on the recovery of marine and island ecosystems at unprecedented scales, and finding ways to make these systems more resilient. We're changing the way that we fish in order to reduce harm and protect ocean wildlife. And we're fighting ocean plastic by cutting production and pollution. And the Nature Conservancy in California is positioned to help lead the way in shaping and advancing this plan. We're transforming California into a hub of conservation innovation where we develop the approaches and tools that can restore abundance and can also reshape the future of ocean conservation. So you might be asking, well, that all sounds great, but what does that actually look like? Well, it starts with protecting critical marine habitats. Just like in land conservation, protecting the most important marine areas is foundational to restoring health and abundance in our oceans as well. And one of the first major outcomes for the Nature Conservancy's California Oceans Program was our team's leadership in siting 124 marine protected areas across the state of California. More recently, our team led in the collaborative development and siting of habitat protections across the West Coast that now total more than 173 million acres. That's an area larger than the state of Texas. And these are incredible outcomes, but we need to continue to build on this work. The science is clear that to achieve our ambitious goals, we can't just protect, but also have to recover these ecosystems at unprecedented scales. And to do this, we need to move beyond existing restoration approaches that simply cannot scale to meet the challenges we face today. Without a doubt, and I really want to stress this point, there has been great work done in marine and coastal restoration by place-based teams all around the world. Yet these folks are often siloed and under-resourced. They're sometimes dubious of new approaches, and they lack experience in key aspects of taking this work to scale, from technology development to scaled production to transactional approaches. In fact, they're often much more, and understandably more, focused on marginal gains, getting a little bit more funding to do 1 or 2 or 3% more next year. The result too often are restoration projects the size of swimming pools, when they need to be the size of cities. To overcome these challenges and restore ocean ecosystems at truly transformative scales, our team is working to develop new technologies and industrial processes and design to radically increase the pace at which we can recover some of the most important ocean ecosystems, like kelp and seagrass, native oysters, and coral reefs. Rather than focusing on developing moonshot technologies, we're trying to leverage TNC's decades of experience and credibility and the many insights from the bright spots in our place-based conservation work around the world, as well as leveraging the unique capacity and expertise and resources we have here in California to build new solutions. This is a multifaceted effort, and our team is redefining what's possible. We're engaging seafood harvesters to help reset devastated kelp forest ecosystems, creating profit opportunities for commercial urchin harvesters aligned with our restoration goals. We're working with researchers to launch the first ever captive breeding and recovery program for the critically endangered marine predator species, the sunflower sea star, a species that is essential for resilient kelp forests. We're partnering with Hog Island Oyster Company and others to leverage their shellfish aquaculture expertise and capacity to grow and outplant native oysters at new scales across the West Coast. And we're building new technologies to help us radically increase the global production of coral for restoration projects. That means leveraging automation solutions transferred from sectors like precision agriculture and commercial aquaculture to increase the scale and reduce the cost of restoring coral reefs around the world. We're on track to increase the annual land-based production of coral for restoration by 100-fold and reduce the cost of each coral produced by 90%, allowing every dollar invested in coral conservation to have a bigger impact. And we're now launching high production coral farms in the Dominican Republic and in French Polynesia to help us demonstrate what's possible with these new approaches. Our goal in all of this work is to reimagine what successful habitat restoration looks like at scale, and to build the tools that can help us make that a reality. But of course, in addition to protection and restoration, we also need to address the growing human-driven threats to ocean ecosystems. And over the last few years, I know many of us have been waking up to the horrible global challenge of plastic pollution. Around the world, a staggering 8 million metric tons of plastics enter the ocean every single year. And that number is on track to quadruple by 2050. And that is just a shocking amount of waste. At this point, plastics have been found in every corner of the ocean, from surface to seafloor, from pole to pole, from coastal waters to the deepest marine trenches. And all this plastic is already having serious impacts on ocean species. To address this, our team is taking a strategic and data-driven approach to drastically reducing production and consumption and emissions of plastics into the environment. In just 3 years since we launched this work, TNC's helped pass the most ambitious and comprehensive state legislation anywhere in the country to fight single-use plastics. This is Senate Bill 54 in California. And we positioned California on the forward edge of efforts to address this issue. Just this week, our team's leader on this work, Dr. Alexis Jackson, is in Nairobi, Kenya, working with the United Nations and others to help inform and shape the first ever binding international treaty to reduce plastic pollution. We're taking the lessons we've learned and the change we've made here in California to the global stage to truly drive change. And of course, in addition to pollution, we also have to address the sustainability of fisheries. Around the world, unsustainable fishing threatens ocean health and the very survival of key marine species. But fisheries also represent a really unique opportunity. Because more than 1/3 of the fisheries around the world are over-harvested or are declining due to poor management, $80 billion in potential fisheries revenue is lost annually, along with countless jobs and huge amounts of protein that people rely on. So you don't have to be a bleeding heart conservationist to care about sustainable fisheries. You might just care about food or money or jobs in your community. And this reality, this potential alignment of interests, is essential to building solutions for fisheries. And for more than a decade, TNC has been at the forefront of doing just that, at the forefront of sustainability in fisheries all around the world. And through this work, we've learned a ton about the underlying challenges and the key enabling conditions that are essential for making durable change. And one of the biggest issues that we've observed all over is that fishing communities often don't have the data to make sure that their fisheries are sustainable. 40% of the world's fisheries are small scale, meaning they often don't have the infrastructure or science to know when they're catching too much. Our team's been hard at work designing better solutions that can meet this information challenge, powerful new tools that can deliver much needed data cheaper and faster. Among these is something that we call fishkit. Fishkit is a revolutionary software tool that we've built that translates digital images of catch. So these are pictures from a digital camera or a smartphone of the harvested fish or scallops or clams, and it turns those images into action-ready data sets to inform sustainable fishing limits for small-scale fisheries. The traditional stock assessment approach that's often seen as the gold standard in the US and many other places around the world routinely takes 3 to 5 years and costs tens, if not hundreds of thousands of dollars to complete a stock assessment for just one species. Fishkit allows a community group to gather much needed stock health information and use it to guide action literally overnight, allowing fishing communities to better protect their fish stocks in almost real time and virtually for free. This tool is a potential game changer for fisheries all around the world. Looking forward, our goal is to deploy fishkit in thousands of unmeasured and unmanaged fisheries around the globe. We're currently working to scale fishkit in more than 50 communities in Mexico, Hawaii, French Polynesia, and Micronesia. We believe we can fundamentally change how we gather information to help improve the management of fisheries. And in doing so, we can take an important step toward the more sustainable harvest of marine resources, securing a more healthy and resilient ocean, but also more abundant and secure food systems for billions of people. Finally, as I mentioned earlier, the health of island ecosystems are inextricably linked to ocean health. And we're only now really beginning to recognize just how important these connections are. While representing just 5% of the Earth's total land area, islands host an extraordinary concentration of unique species. They cycle nutrients that keeps reefs and oceans healthy, and they support the health and livelihoods of communities all around the world. Unfortunately, islands are also hotspots for extinction. Over time, threats like invasive species and habitat loss have dramatically transformed these landscapes, culminating in species extinction and wholesale ecological collapse. Among the most vulnerable and impacted island species are seabirds. And though there are many aspects of addressing the decline of seabirds, one of the most important is reversing the loss of critical seabird nesting habitat on islands. Across the tropical Pacific and through the conversion of native atoll forests to single crop coconut palm agriculture, we have lost a staggering 40% of the essential nesting habitat for seabirds. And yet recently, the economic value of these coconut palm agriculture operations has declined, especially on remote islands and atolls. And this creates a pretty exciting opportunity for conservation. At our remote Palmyra Atoll Preserve, which is about 1,000 miles south of Hawaii, TNC scientists have demonstrated that not only can we convert the atoll's abandoned coconut palm plantation back into native forest species, but doing so supports the recovery of vulnerable seabird populations and leads to healthier coral reefs. Our team's now focused on how we can take this work to scale across the Pacific, reversing the patterns of loss and decline and reshaping the future for island ecosystems and for the people that rely on them. When I step back and think about what allows TNC to advance our mission in a changed and changing world, I always come back to our core strength, the thing that makes us unique. And that is that TNC is one of the only organizations on the planet with a track record of solving planet-sized problems. Since we were founded about 70 years ago, we've worked with a whole range of partners, bringing science and technology to help build win-win solutions. We know we can solve these problems, and our science has given us a roadmap for turning the tide and recovering and restoring abundance to our oceans. If we change course now, and if we do it together, we can shape a better future for the world's oceans, for the planet, and for ourselves. The work I've outlined here today is big and bold and ambitious because it has to be. We have to move fast if we want to change the trajectory of our oceans. But the thing that I want to stress and the thing I want to leave you all with today is that we can do this. We can solve big problems, and we have a plan to make it happen. One thing that I constantly remind myself as I approach this work is that not that long ago, oceans around the world were abundant and teeming with life. And while many of the issues that we're working on and working hard to address have existed for centuries, much of the most significant damage has occurred in basically the blink of an eye from a planetary perspective, just the last few decades. And I think if these problems can advance this quickly, so too can the solutions. The future of oceans can be much brighter, but the thing that needs to change is us. Humans have created these problems, and we can and must fix them. But to do that, we need to think much bigger, and we need to act urgently. And I'm proud to say that TNC is working with partners all around the world to do just that. Thanks.
All right. Thank you so much, Tom. It's great to hear your expertise, and we so value your voice and your team's voice. So at this point, we have the opportunity to ask questions of Tom and Jono Wilson, who is our chief scientist for the Oceans Program in California, director of science, I should say correctly. And Jono, you're amazing, and Tom, you're amazing. So this is an opportunity for all of us to ask questions. I want to really thank people that have already put questions in the Q&A function, and we have a few to start us off, but if you have other questions, please put them in the Q&A function. So at this point, let's just get started. So with the wide range of environmental oceans challenges, how does TNC prioritize its efforts and measure success?
I can take that. So as Tom hinted at, the Nature Conservancy, we operate in 70 different countries. And so we have this really unique perspective, and as well as in all 50 US states, we have this really unique perspective in which we have place-based organizations on the ground who are working with people to understand what the challenges they face are. At the same time, we have this global lens, this global perspective to understand what those larger challenges are that are affecting the entire planet. And so from our perspective here in California, we have this unique opportunity to really think about how we can work with place-based teams to solve local challenges, while at the same time scaling those solutions to the broader globe. And so we really think about those biodiversity challenges that we can bring our unique perspective to, that we have a unique niche and we can leverage our experience, our skills, and our the ability of our teammates to go and affect change on the ground. And so I think it's just a really unique opportunity for we as TNC in California to go and identify these problems and make change across the globe.
Excellent. Thank you. So second question. And again, I just want to say these questions were asked for in advance of this session. So thank you to those that submitted them. What human impact causes the most harm to creatures in our oceans, such as whales, dolphins, and sea turtles?
Yeah, there are so many different threats, all happening at once, as I sort of alluded to earlier. I think one of the major threats to wildlife species like whales and turtles is interactions with fishing gear. And so accidental entanglements happen as nets or lines and buoys are left out in the water. And that's been a big focus of our team over the last 5 years, especially here along the West Coast in terms of the Dungeness crab fishery, which is one of the largest commercial fisheries on the West Coast. We've worked with harvesters and researchers and the state and federal resource managers to create cutting-edge solutions to help ensure that we can have thriving fisheries, but also reduce the risk of entanglements for whales and sea turtles. So we've done a lot of work in that space, and I think really set the bar in terms of commercial fisheries taking a proactive approach to reducing entanglements. But that, unfortunately, is one of the primary global threats to the recovery of some of those species.
Boy. All right. Thank you, Tom. Okay, the next question is, please address microfibers and microplastics and what we can do to stop them from entering the ocean.
Ah, fantastic. So when we first got started, and this, again, as I mentioned, it wasn't that long ago that we really first got started thinking about how we could add value as an organization, what we could really bring, and how we could move the needle on this complex global challenge of plastics. And from the outset, I think microplastics and microfibers at that time were kind of were less emphasized, certainly than things like plastic bags and straws, and what we think of as macroplastics, so things that you could hold in your hand. And so we started to really explore, particularly on microfibers, what the sort of overall nature of that problem is, and how it's trending over time, and how we could build solutions. And where we got to is taking an end-to-end approach. So when we first got involved, almost all the energy that was going into addressing microfibers and microplastics globally was aimed at voluntary in-home retail-based solutions to capture microfibers as they shed, as we wash our synthetic clothes. And we thought that we needed to take a much broader approach and more strategic approach. So we actually worked with our partners at Bain Consulting to do the first ever global estimate of all the microfiber emissions from the manufacturing and processing of synthetic textiles. So many of you probably know, you're probably wearing synthetic textiles right now. That part of the textile market has exploded. It continues to increase. And in the production and manufacturing of those materials, what we found is the fiber fragmentation. So the mechanical processes that pull off these tiny plastic fibers and put those out into wastewater, those are actually contributing almost, if not more than, all the fiber fragments coming from our clothes during our laundry and everyday use. And so we've been working upstream with some of the biggest apparel brands and textile firms all around the world to implement really important and cost-effective solutions to reduce the shedding of those fabrics so they can make better choices and pick better fabrics and textiles as they develop their products, but also actually incorporating high-end capture solutions that can bring down the sort of microfiber pollution by 99%. And so we're now looking to build brand commitments that support that work, and then ultimately try to transform that sector so that the manufacturing and processing step takes a lot less or has a lot less impact in terms of plastic pollution. Simultaneously, just this past legislative cycle here in California, we worked to advance a state bill to require manufacturers to include filters, microfiber filters, in all new washing machines. Unfortunately, that didn't make it over the line into signed law, but we're going to take another run at that because I think, again, we need to take an end-to-end approach, particularly on something like microfibers. And I think the Nature Conservancy is one of the only groups that can work on the upstream side in partnerships with corporations and brands, but also work on the policy side in terms of advancing some ambitious proposals to really address the solution further down in the pipeline.
Wow. That's extremely hopeful and valuable. And I would just reiterate that we are doing this in California on behalf of the global organization. There's really no other plastics program or function within TNC. And I love that about California's oceans program, that we're on the forefront of a lot of really incredibly important issues. And we have great partners in California in the industry to help us along. So love that. Okay, last of the pre-submitted questions, and then we'll get to the ones that are in the Q&A function. So how can we reduce pesticides, farm animal, and industrial runoff from entering our oceans, knowing that they are a problem? So
yeah, it's a great question. And I think one of the things that historically conservation has really been challenged by is that we really artificially create silos between some of these issue areas, when of course we know that everything that flows down our streams and rivers, so everything that we do upstream and on land, ultimately impacts the ocean, whether that's plastics or pesticides or other things. And so one of the great things about the Nature Conservancy is we, the oceans team, are just one of 4 programs. So we have 4 program areas. We have a land, a freshwater, an oceans team, and a climate team. And we're able to really collaborate across those teams to build comprehensive solutions, like what I was talking about, frankly, with microfibers, but end-to-end solutions. So we have teams that are working on more sustainable, more responsible agriculture practices, including the diminished use of pesticides, the strategic and effective and accountable use of water resources, as well as how we protect riparian or river and stream beds from the impact of both pesticides and inputs, but also the sedimentation. And just recently, as we've worked hard and launched this work around ocean recovery in California, as I mentioned, one of the primary marine and coastal habitats that are most important, that really drive diversity in our coastal zone, is eelgrass. And the eelgrass across California has diminished by more than 90%, and a lot of that has been driven by pollution and sedimentation coming in from streams and rivers. And so as we think about how we scale restoration and how we site restoration, we also are working with our teams in the land program, the water program upstream, to ensure that we're really diminishing, reducing those pesticide inputs and the sedimentation inputs that can result from unsustainable and irresponsible ag practices. So we try to take a whole system approach to that issue and others.
well, that's really exciting. Thank you, Tom. Okay, so we're going to get to several other questions I think we have time for. So there's a couple of questions around kelp. One is around the G2KR, I think, which is giant kelp program in Monterey. Are we involved? And then another one just about like our kelp program in general and how we are helping to bring back kelp along the North Coast and Central Coast too.
Donna, you want to take that one?
Sure, happy to. So yeah, our kelp program started about About 5 years ago, so as many of you may be aware, on the north coast of California, we've lost about 96% of our kelp forests over the past decade. And really that stemmed from a couple different things. One was a warming event that caused the decimation of existing kelp stands. Similar to that, in a couple of years prior to that, there was a sea star wasting disease that spread across California and the West Coast. And it actually destroyed one of the main predators of a primary herbivore in the system, and that's purple urchin. So we lost this predatory sea star. The purple urchins were allowed to proliferate by the billions on the north coast of California. And so then when we lost the kelp through this warming event, what happened was juvenile kelp that tried to recruit back into that system to put their roots down on the rocks and grow up into giant kelp or into bull kelp, mature bull kelp stands. What happened was those billions of purple urchins began to just continue to eat them. And so to date, we have not had a return of our kelp forests on the North Coast. And that's been just absolutely devastating for businesses on the North Coast, for commercial fisheries, for biodiversity's sake. And so about 5 years ago, when we looked around and saw that this problem was happening and that nobody was really taking action, we stood up a very large kelp restoration program. And so we have now expanded that restoration program along the entire North Coast to do a few different types of things. And that is working, as Tom mentioned earlier, working with commercial fishermen and the industry and other partners up on the North Coast to actually try and experiment and deploy new technologies to remove those urchins out of the system. We've also been, as Tom put it, piloting a program to actually return the sunflower sea stars to the water in great numbers. And so we're actually seeing that we're having some impact. The bull kelp that we are restoring is actually coming back, and we've had some early successes in that just this past summer. And so we're beginning to now look across the entire coast of California, and we've recognized, and some of our science has shown, that it's not just kelp on the North Coast, that actually Central California and Monterey, as well as in Southern California, we've lost kelp over the past several decades. And so there are a number of partners on the ground right now in Monterey that are actively out there in the water, outplanting kelp, removing urchins. There's a great experiment happening right now at Tanker Reef in Monterey. And so we've been a part of that whole program, partnering with those folks in Monterey, partnering with folks down in Southern California to really try and see how we can leverage some lessons that we've learned up on the North Coast, bring those to Central and Southern California, but also learn from those partners and take some of their experiences up to the North Coast. We've actually made, not just in California, but we've made significant impact in bringing some of these lessons across the globe as well. We pioneered a mapping tool that is called Kelp Watch, kelpwatch.org. You can check it out online. And this is the world's first and foremost kelp mapping tool, where we have taken 30 years of satellite information to map kelp forests over time along the coast of California. That program has been so successful and led to so much information on where to prioritize restoration. What can we learn about the dynamics of kelp forest ecosystems, that partners across the globe have requested the development of this Kelp Watch tool to their geography. So we've now begun bringing it to Canada, to Chile, to Australia, and a whole bunch of other geographies across the globe. So what we're doing here in California is really having a big impact on kelp forest ecosystems across the globe.
Wow, that's so fantastic, and it's so encouraging to hear. And I know we're all concerned about our kelp forests, and it's such a signature of Monterey for sure. So thank you. And I just wanted to reiterate, which is something that Jono referenced, we have some resources in chat. So if you look in there and can click on those, there are a lot of other places to go for information. Okay, we've had several questions about offshore wind. So what do we think about it? What do we think about it in California, and think about it in general?
Yeah, fantastic. And this has been obviously an expanding issue of focus. And we've been working really closely, as I mentioned earlier, as we think about the sort of partnerships across our teams. We've been working really closely with our climate program, which has really been at the forefront of siting renewable energy projects on land. And I think our first principles is we have to reduce our emissions. We have to decarbonize. I think California has some really exciting and ambitious renewable energy goals, and we want to help California achieve those. And I think we're playing a really significant role in doing that across the Conservancy. And where those projects go matters. And we need to be really thoughtful in siting. We need to, right now, I think one of the things that we can and need to continue doing is really understanding the baseline context in the ocean. So there are several things that offshore wind turbines can impact. They can impact seabirds and bird life, cetaceans like whales, and disrupt whale migration and have impacts on those populations. And also, even more recently, there's been new information with regards to the impacts on upwelling. So upwelling is when cold, nutrient-rich water comes down up from the deep water into the surface water. And that's one of the fundamental drivers of productivity and biodiversity and health in our coastal ecosystems in California. So we're really narrowing in and trying to understand all those impacts and to make smart decisions. But at the end of the day, I think offshore wind, according to our climate team's own science, is going to be a significant and important part of the renewable energy picture. It probably won't be a major part, but it's going to be essential to achieving our overall ambitious targets. So where we are on that is, how do we ensure that we're doing that in a thoughtful, science-driven, and inclusive way that expedites the siting and build out of responsible projects, but avoids unintended consequences for natural systems and for ocean health?
All right, thank you, Tom. And so I think we're going to get back to sea urchins. So, and this is, you can answer it probably pretty quickly, but there was a thought about, like, when sea urchins are starved, they've eaten all the kelp that they can eat, and they're just kind of wasting away. What's the point? What value do they have? Why, when we harvest them, what do we do with them? Like, just give us a little bit more about how we're thinking about sea urchins and their value in the market, etc.
Sure, I can take that. So there is a practice called urchin ranching, whereby fishers can go out into the water and remove what we call zombie urchins. So these are those urchins that have created these barrens of area in which the kelp has been depleted. And so those urchins can actually live in that zombie-like state without eating for a long time, for many years, it's presumed. And so fishers will go out into the water, they'll collect those urchins, and they'll actually bring them onto land, or subtitally, but in this case, onto land into tanks where running seawater can flow through these systems, and a kelp-like or kelp product can be fed to these urchins and actually fatten them up. These urchins have value in the marketplace because they're eaten in the sushi markets. Their eggs are actually, when ripe, are a delicacy. And so by feeding them in these tanks on land, you can fatten up these urchins and then sell them in the marketplace. And so we've been working with a number of partners up and down the coast to actually develop a product, a feed product that is able to be sourced widely for a very cheap cost. So anybody in this who wants to get into this market can actually go harvest urchins, feed those animals this product. And we've developed a couple of user guides and manuals, how-to guides to develop your own urchin ranching operations, assuming you can get the permits. And so we think that this is one of the mechanisms that will be instrumental in helping to remove and reduce the native purple urchin population that has proliferated in recent years, and hopefully return the kelp to these ecosystems.
Awesome. I love how we're trying to help entrepreneurs. Okay, so we have a question from Bruce about, how does fishkit work?
Yeah, I'm happy to take that. So one of the things that's exciting about fishkit is rather than the traditional stock assessment approaches that I mentioned that are focused on basically trying to estimate how many fish are in the sea, right? So there's a whole bunch of science and established practice for how to estimate how many fish or lobsters or crabs are in the water. That's very hard to do, but we have great science to help do that. The problem is, as I mentioned, it's slow and it's really costly, and it takes a bunch of PhDs to go and do the math and science involved with many of those practices. What fishkit is able to do is rather than counting how many or estimating how many fish are in the water, we look at length. And recently, over the last few years, what's become clear is that evaluating the length of individuals that you're harvesting, whether that's fish or scallops or lobsters, evaluating the length of those individuals can actually populate and inform a stock health index. And it can actually tell you whether, if you don't have enough small ones or you don't have enough big ones, you might be overfishing. And so what we do is we take those digital images of the catch, as I mentioned, individual lobsters or fish, and we build a length-based data set automatically, basically using computer vision and machine learning to take a really precise measurement of the length of that individual, goes into a data set, and then we use some new scientific approaches that actually my friend Jono Wilson helped to lead in developing and proving out. We use some of those length-based approaches to evaluate the health of that resource, whether it's trending up or trending down or about even, and then actually inform management measures. And what I mean by that, it can be a size limit, which is a limit or a length below which you can't harvest that animal. So you have to throw that lobster back, for instance. And what that allows us to do is ensure that more and more, frankly, all of the individuals in that population get to a size where they can reproduce at least once before they're harvested. If you're catching individuals and harvesting too much on the smaller size classes, you're going to run into trouble. So you can do a size limit, which is one of the measures that fishkit helps inform, and or you can do a bag limit, which is basically a total amount that you can harvest in a day. We have the ability through fishkit to work with community partners to use their own collected information to run through that process, to make recommendations for some of those changes, and then actually adjust that dial and make some trade-off decisions on their own with regards to their own management goals to say, okay, here's where we want to be. We want to make these changes and implement this so as to achieve these outcomes and ultimately achieve a stronger, more robust, more profitable and sustainable fishery. And that's what we've seen in the early cases. So we've worked with fishkit in Mexico, French Polynesia, a number of different places. And we worked with communities that recognize that they need science, they need information, and they need to turn that into a management response, but they don't have the capacity to do that. That's where fishkit really can add a lot of value. And that's our plan for it and how it works.
Excellent. That's wonderful. So getting back to the map that we showed earlier on in the presentation, there was just a question about what did the three colors correspond to, tiers of protection and management. So I don't know if you remember it, but can we speak to that?
Jono, you want to take that one?
Yeah, I'm trying to recall what they were. I believe they were different types of protection. So there was an actual notake protected, which is the smaller coastally focused areas. And then there was no trawl zones. And then there was essential fish habitat. I believe those were the three, if I'm not mistaken.
Thank you, Jono. And sorry, in the future, we can make our, the notations a little bit more clear for people that are on the video. Okay.
Yeah, just following up on that really quickly. I think, to the crux of that question, which is we can't shut down all of the ocean, just as we can't shut down, all land, although maybe that's what would benefit nature the most. That's just not a viable solution from a number of standpoints. And so we do need to have what we think of as no-take reserves. That means where you can't go in recreationally or commercially and harvest anything. You can't even pick up a shell to bring it home. Those are areas that are specifically protected at the fullest possible extent for nature. We have other protections and other levels of protection that allow certain less impactful activities. And then we have the sort of broadest protection is identifying areas that are essential for fish habitat. So from the most protective spot where there's no take, no harvest, there can be levels of protection. And obviously those are kind of science-driven, hopefully, and responsible, but allow for the most sustainable and responsible harvest in those certain areas where it's most appropriate.
Thank you. And I was very, interested by our staff meeting today where we looked at a study that showed how much of our coast was a wild coast, how much was protected, and how much was protected along the in the ocean sphere too, along the coastline. So that was it was very surprising to see how little was really protected. So we will be pursuing that in the future as well. Rick is asking a question about fly fisher people, fly fishers. So in the ocean sphere, I think, do they do harm? Is the unintentional killing of some percentage of the fish that they throw back something we should be concerned about? So maybe from that sport fishing standpoint.
Well, it's always a concern when fish are removed and there's significant mortality. Their fly fishing by nature is generally considered a little bit less intrusive, primarily when there is catch and release approaches that are undertaken. The state of California does a really good job of managing their fisheries. And so what I mean by that is that they have data sets up and down the coast that monitor the health of many fish stocks in California. Those include the commercially harvested fish stocks, as well as the recreationally harvested fish stocks. So generally speaking, if a fisherman or fisherwoman is allowed to obtain a permit for a fish in California, there are certain restrictions that come with that permit. You can take so many fish, you can only fish in designated areas. And generally speaking, if we stick to those practices and those rules and regulations, that the fish stocks will generally be healthy in the state of California.
Excellent. That's good to know. All right, so we have another question about that's more at the international level. What level of cooperation are we getting from countries like China, Japan, Malaysia, and others around major fishing nations? So a little bit out of the area that we've been talking about for the presentation, but can we speak to that?
Yeah, I think I'll say just a few things. So we have, and I do not lead, but and work closely with a large-scale fisheries team, which is part of our global Nature Conservancy team. And they've been working around the world on some of the largest, most profitable fisheries around the world, including things like tuna and shrimp. And I guess the nature of our interactions with some of those countries and many others is kind of twofold. One of the things that I think is a strength of the Nature Conservancy is we have place-based teams, as John referenced earlier, in over 70 countries around the world. And so we are there and not and we are there with local representatives and local staff and teams that are driving their own priorities and ensuring that their conservation work aligns with the local context and is locally supported and responsible. And so we have this incredible network, this global footprint of place-based teams that are working in so many of these different countries. And they're working on ocean issues, they're working on land practices, they're working on policy and climate, et cetera. And of course, that work looks different from one country to the next, no doubt. I think in the large-scale fisheries work, large-scale fisheries like tuna operate in a really multinational way. A lot of that work, say in the Pacific, is led by a whole range of countries that are active in those fisheries that support vessels to go and fish off places like Palau, but many others. And so we've been really hard at work defining and driving forward right-sized solutions to A, get better information on the health and trajectory of those stocks using new tools, and B, actually get more accountability on some of those vessels and some of those fisheries. So one of the things, as we mentioned, that is foundational as a challenge in fisheries is the lack of ability to answer a couple of really key questions. One is basically, how healthy is your resource that you're harvesting from? The other is, how much are you harvesting? And many fisheries, including some of the biggest in the world, really struggle to answer those two fundamental questions. And if you don't have the answers to those questions, you really can't be sustainable and adaptive in terms of your management, and you're not going to be successful. So a big part of what we've been working on in collaboration with some vessels and corporations from some of those countries and governments is driving forward accountability. So using new tools to actually gather information on vessels in terms of what their harvest is in terms of directed catch, but also what some of their impacts are on the things that they're not trying to interact with like dolphins and turtles and sharks, so we can get a handle on those sustainability challenges as well. So it's a big answer. The nature of our involvement with different countries varies from place to place. But I think one of the things that makes us really productive and effective as an organization is engaging governments where they are, engaging successfully with corporations, not because we love, profitable fisheries so much, but that we see the value in them and that we see the need to engage really constructively with a whole range of partners, including those that rely on the resource that we're trying to protect and conserve.
Thank you, Tom. And I know electronic monitoring is something that we've really been a proponent of and wanting to see it rolled out, and the uptake from various nations to agree that that's something that we need to invest in. And who should invest in it, I know is the question. But anyway, let's go on. So great question here about what is our engagement or thought about deep seabed mining? We know that is a threat to
I
ocean.
can take this. I mean, it's been in the news quite a bit. There's obviously meetings ongoing and discussions ongoing right now. And I think it's it's fascinating. So it's not one of the issues that we have prioritized to this point, although we're tracking it really closely. So if folks aren't familiar, so deep sea mining is the idea that we would go and extract using new tools in very deep ocean areas and some sensitive areas to pull up minerals and metals that are very rare in other parts of the planet, and that are essential for making at least some of the batteries that are going to drive our renewable energy infrastructure. And so it's a complicated issue. And over the last 5+ years, a lot of people have been saying, well, this is this hefty and difficult decision. We're going to need to decide to mine these or somewhere because we certainly don't want to slow down our transition to renewable energy, and batteries are such a key part of that. One of the exciting things about that is that as of today, we're seeing more and more alternative batteries make it to market. About a third of the batteries currently in some of the EV models that are coming off the line now do not actually rely on the minerals and metals that would be mined in this way, that would be mined in the deep sea. So there is some hope and optimism that we can actually not have to make this really difficult decision about mining the deep sea in some sensitive areas to support the renewable energy push. We might be able to achieve that really important, most central goal in a different way without those kinds of impacts. So regardless, whether you're talking about any ocean issue, whether it's trawling for fish or offshore wind or mining, I think you really have to be eyes wide open at the outset with regards to what is the benefit, a collective community benefit of that activity? What is really driving your need to conduct that activity? Can it be done sustainably? And if so, where can we cite that? Because as we've found in our fisheries work, there are some fishing practices that just cannot occur in certain areas, and we need to set those areas aside. And there are some fishing practices that can occur sustainably in many parts of the ocean. Deep sea mining is a different animal. It's a different issue, but I think that's how we're thinking about it. I certainly wouldn't advocate for that unless there was ultimately no other way to achieve our climate and renewable energy goals. And I'm more and more confident that I think we won't need to do that at any significant scale. So I hope we can avoid it.
Thank you, Tom. Thank you. And I know we're getting to time, so I think this is going to be our last question. I just want to thank people for submitting questions, both in the chat and the Q&A function. And to the degree that we can get back to, we will. So with this, I would just like Tom has asked a question. Are a lot of TNC's California marine efforts aimed more at improved management or new MPAs? And he's thinking about TNC's 2030 goals here. Yeah,
I mean, I think around the world, there's a kind of a different answer for that based on geography. And that again gets to our strength as an organization, is we have the ability to align around big picture kind of North Star goals as an organization globally, but we have some latitude and flexibility to set priorities using place-based teams and local science and the context that we're operating in to kind of balance out our focus on protections versus things like managing harvest or managing use. Right now, frankly, after some of the recent milestones that we've achieved as a program, at least in California, much of our effort is on managing natural resources more sustainably and managing the practices and activities that happen in the ocean. And more is around recovery and restoration. I think over time, if you look back over the last 30 years of ocean conservation here in California, but also around the world, we've kind of had a two-legged stool, by and large, if you look at macro trends, where we're really focused on managing and we're really focused on protection. And of course, there's a lot of work being done and a lot of work still to do in those areas. But where we're increasingly focused is we recognize now that we need to continue with protections, we need to manage more sustainably. But in order to achieve our top line goal of restoring abundance and resilience to oceans, we need to recover ocean ecosystems and species in ways that we never have before. And so that's a big and growing part of our program's portfolio is how can we do that, bringing all the expertise and capacity from California to build the solutions that can scale and help us do that here, but also all around the world. So that's how our sort of balance looks like today.
That's so encouraging. And for those of you that are with us, you probably know that TNC is very habitat oriented. So we believe if you provide the fundamentals, that species will grow. And that's kind of where we are at. We are bringing back kelp, we're bringing back oysters, we're bringing back seagrass. We're restoring the natural systems along the coastline so that other creatures can grow and thrive. So it's so exciting. And we thank you for being with us and thank you for your support, because without you, we're not doing this, basically. So please message us or get a hold of us, and we will respond to your questions that you've submitted. But we love to hear from you about what you think about what we're doing, how you'd like to engage with us in the future, and give all the kudos and compliments to Jono and Tom, because, you know, we all love props. So thank you for spending your lunch hour with us. We hope that you will join us in the future. And thank you for everything that you're doing today. Happy Wednesday, and we will say goodbye.
Thanks so much. Take care.
Okay, bye.